In part 1 of making bonds lesson, we looked at ionic bonding in particular. These set of substances here contains ions, and which means charged particles, and we looked at how they join up together, what keeps them together, and how they are bonded, in other words. This lesson is about covalent substances. These two sets of substances which are bordered with red color. So we're going to be looking at how these substances, the atoms in these substances, are linked and joined together, and why sometimes you see three lines, three bonds linking the atoms together, and why they come in pairs, why they join up in this way, and how. So we're going to be looking at just covalent substances and not ionic. So if you want to know about ionic substances, you really need to revisit Making Bonds Part 1, where we look at the mechanisms of how ionic bonding works. Now in this lesson, we're going to go ahead and look at compounds, covalent compounds and covalent elements. Substances which can be termed as compounds and elements we've already looked at before in previous lessons where we learned about elements and compounds. So this lesson is just about how the atoms in covalent substances are joined up together. We have already looked at the basic definitions for covalent substances. You would look for atoms in that substance, and it should be of non-metals. So if a substance is made up of just non-metal atoms, then you know it's a covalent substance. If you have a metal and a non-metal in a particular substance, then you look for, then you know that it's an ionic substance. Again, the outer shell electrons play a key part in the bonding process, and it's a really important idea to have and understand what this means and how that determines the number of bonds and how the bonds are made in both cases, ionic and covalent. Noble gas electronic arrangement. As we already seen, noble gases such as helium, neon, argon, krypton, they all have full outer shell. We will have a quick look at where these noble gases are in a periodic table and what we mean by noble gas electron arrangement and how that make it very stable. Let's have a look at periodic table quickly before we move on into covalent bonding. What I wanted to point out is this hydrogen here is in a unique position in the periodic table. It has one electron on its outer shell, so you may think that this is part of group 1. But it's not. It's kept separately for a reason, and main reason being it's not metallic, it's not a conductor, and it's not a solid. It has many differences when you compare hydrogen's properties with that of the group 1. So it's kept separate all the time. So that's really important to bear in mind. This one does form covalent bonds. So bear that in mind when we think about covalent bonds are formed between substances of non-metals. Hydrogen is a non-metal, so you should consider that as a non-metal when you look at a compound such as H2O. You would expect covalent bonding because hydrogen is a non-metal. Just a brief reminder, the group numbers represents the number of outer shell electrons. Group number 2, all these metals will have 2 electrons on its outer shell. Group 3 will have 3 and 4 and 5. These are transition metals, and unless you're told, you will not be able to say exactly how many electrons on the outer shell. So ignore this for the moment. We are dealing with group 1, 2, 3, 4, 5, 6, 7 elements. So the group number represents the number of outer shell electrons. Let's have a close look at these noble gases over here in the last column, which is called as group 0 or group 8. So let's have a look at how the electron arrangement are in those elements in the noble gas column. Okay, so let's make this bigger, like that, like so. Let's have a look at the first few, and this is the same pattern in the rest of it. Okay, let's look at helium's electronic arrangement, which is it's got 2 electrons in total. That the 2 represents a proton number, but we know that's electron. It's equal to electron number in a neutral atom. So helium's electronic configuration goes like that. And we say that's full outer shell. That's because the first shell, if you can remember from our rule, the first shell can only have a maximum of 2, and the second have 8, and 8 on the third shell. So if these conditions are met, if the if the first shell contains 2 electrons, then we say it's full. Second shell, if it contains 8 electrons, we know it's full shell. Third shell, again the same thing. If it contains 8, it's full shell. So let's have a look. Helium has got 2, just one shell, which means it's got a full outer shell, and that makes it very unreactive and also very stable. Okay, so let's have a look at neon. Neon has got 10 electrons, so its electronic arrangement will be 2 8, and similarly argon 2 8 8. And in the same way krypton works. It has a full outer shell as well, but we don't need to know past argon, because then we go past the into higher atomic number. We really don't need to know about these elements, but they also have full outer shell. So it is really important to understand this idea that all the other atoms, by making bonds and by making either covalent bond or ionic bond, they try to achieve a full outer shell, because that makes them stable, and make them look like this arrangement. They achieve a noble gas electronic arrangement. So it's really important to understand that is the reason for why they form bonds, be it ionic or covalent. Okay, let's have a look at how we use a specific number of steps to be able to describe a covalent substance. And I've chosen water, being a simple, but yet it's a compound, and we can have a look at how the bonds are made. Let's start with this one and apply the first step here. Check if the substance contains only non-metals. And it's a really important check, because sometimes you're just given the substance and you're not told whether it's ionic or covalent. So you have to decide whether it's ionic or covalent before you go any further. Now, so that's the first thing to check. Is that really a covalent substance? And so yes, it does fulfill that criteria. It contains only non-metals, so it is a covalent substance. And in this case, we also know it's a compound, as it contains 2 different elements, hydrogen and oxygen. So we can now take that, we've done that, and then we're going to be looking at, make sure we know the number of outer shell electrons, second step. So for hydrogen, because it's in group 1, we know it's got 1 electron only on its first shell. So the first electron is here, hydrogen's 1 electron is here, and we know that because hydrogen is in group 1. And also if we look at the atomic number for hydrogen, it's 1. So for hydrogen atom, this is the electronic arrangement. If you want, you can write it in full, so you're sure about how many electrons it's going to need for a full outer shell. And for oxygen, right, like so, it's in group 6. So oxygen is in group 6, so it will have 6 electrons on its outer shell. But if you want to be safe, you can write the full arrangement just following that rule as we did in atomic structure lesson. Okay, so right in that format. Now this tells you how many more each of these atoms is going to need. Now we know it's covalent compound, so it's going to be sharing the number of electrons, okay, that it's going to need. These compounds are formed by sharing the electrons, unlike the ionic substances where electrons are transferred from the metal to the non-metal atom, if you remember. And if you can't remember, you need to go back to ionic bonding or making bonds lesson part 1. So we are going to be looking at just how covalent bonds are made by the sharing of electrons. Okay, so the electrons are not transferred from one atom to the other, as in the case of ionic. They are shared right in the middle of these atoms. Let's have a look at how that works in this case. Okay, so oxygen has got 6 electrons on its outer shell, and as we've already said, it will try to achieve 8 because the number of electrons 6 is not full. Okay, so it's going to need 2 more electrons. So I'm going to write plus 2. So I know it's going to need 2 more for the full outer shell. Hydrogen is going to need 1 more electron so it can have a full first shell. Okay, so hydrogen. Now we've established how many each of these how many each of these atoms are going to need. Hydrogen is going to need 1. Oxygen is going to need 2. Once we've said that, that is the number of electrons it has to share, and that will be the number of bonds it will make. So we have done step number 2. We know this. Now we're on to step 3 here. Work out how many more electrons each atom. We've done that. So we know how many electrons each of these atoms are going to need for the full shell. Now we know we're on the fourth step here. Now we also know this is the number of bonds each of these atoms going to make. Hydrogen can only make one bond as it needs one electron, and it will share one electron. Oxygen will make two bonds. It will share two electrons to do that. Let's see how that works. Now I'm going to write the atoms over here. And as I said to you, it's going to need two hydrogen, because hydrogen can only share one. You can write like this to plan this, HO, and if you write 2, the number of electrons oxygen is going to need, and the hydrogen needs 1 electron, and swap the numbers over, what you get is that 2, this 2 comes over here, and that 1 goes over there. Okay, so we get an idea about how many atoms are involved by just doing that. So one oxygen is going to be connected with 2 hydrogen atoms. Okay, so let's see how that works. Oxygen has got 6 electrons, so let's put the shared electrons only over here. So oxygen is going to share 2 electrons. We know that by just looking at the number of electrons needed. So I'm going to put that 1 over here and 1 over here. Okay, and it is going to share that with hydrogen. Hydrogen can only share 1 electron. So I'm going to show that over here with a dot. Remember, I'm showing the electrons belonging to hydrogen look different to the electrons that comes from the oxygen. So now you have the shared pair. Now why do I have only 1 electron shared? We know oxygen can share 2 electrons, but hydrogen can only share 1 electron. So in each shared pair, in each pair of electrons, 1 atom should come from both atoms involved in the bonding. So if hydrogen can give on one electron, oxygen has to give 1 for that bond, no more. Okay, so once we have done these 2 electrons, now let's look at how many more outer shell electrons oxygen has got. Remember, oxygen has 6 electrons of its own electrons, out of which 2 has been used. Now that leaves us with 4 more oxygen electrons. So out of the 6, we have used 2 electrons. That leaves us with 4 more electrons of oxygen. So I'm going to show that over here on top of oxygen, just to show that it remains with oxygen. Now any electron we write between the atoms are shared over here. Now planning like this, even before you do anything else, allows you to describe this really well. You can see hydrogen and oxygen shares 1 electron each to form a single bond, and this is what we show as one line. And so oxygen shares 2 electrons, 1 each with 1 hydrogen atom, and hydrogen gives 1 electron for that shared pair. So each hydrogen atom gives 1 electron. So now by doing so, both atoms achieve the full outer shell. Let's see how that is. Hydrogen needs 2. Now these 2 electrons are shared, so it's counted for hydrogen as well. So hydrogen has got 2 electrons now. Oxygen should have 8 because it's got 2 shells. Now if you remember, oxygen's arrangement is 2, 6, so it's got 2 shells. So the second shell, for it to be full, it needs 8 electrons. Now let's count this. 2 here, 2 here, that's 4, 6, 8. I am including the electron from hydrogen as well in the counting. So oxygen has achieved 8 electrons on its outer shell. So as we can see, both these atoms achieve a full outer shell. Now we're going to look at how it is normally represented in the form of dot and cross diagram. It can be shown like this with full all the shells shown for each atom involved in the covalent bond. So that is our oxygen atom here, and these are the 2 hydrogen atoms. Normally it's represented in a diagram called dot and cross diagram. You show some electrons of a particular atom with either dot or cross, just to show the difference between where the electrons are coming from. Okay, now I'm going to draw the oxygen's atom as electrons. As we know, it has 6 electrons in total, so I'm going to show that the first shell has a maximum of 2 so that I've shown that here. We now have to put the shared electrons on the outer shell first. So when you try to draw the diagram like so, you put the shared electrons first. So we know oxygen is going to share 2 electrons in total, but 1 each for one hydrogen atom. Now this is because hydrogen can only share 1 electron from itself, because that's all it's got, and it only needs 1 for the full outer shell. So I'm going to show that over here, the hydrogen's electrons shown with a different color and shape with a dot, and that's what we call that as dot and cross diagram. You can see the electrons from hydrogen are shown in that color, a red dot, and blue crosses for the oxygen's electrons. Now I have not completed all of oxygen's electrons, so I need to go and complete that now. So as we know, oxygen has got 6 electrons on the outer shell. We've done the 2 shared electrons first on the outer shell. Now I'm going to go and do the rest of it, so that leaves us with 4 electrons. You can place it anywhere you like. You can place it like so. So there are 4 electrons on over here, which are not shared. So oxygen's outer shell has 6 electrons. Now after sharing, it has achieved the 8 electrons. As you can see, this is included now. The shared electrons are shown here: 1, 2, 3, 4, 5, 6, 7, 8. So oxygen has achieved a full outer shell. I'm saying this because oxygen has 2 shells, and for the second shell to be full, it needs 8 electrons. Now if you count all these electrons, 1, 2, including the shared pair, that's 4, 6, 8. So oxygen has achieved the full outer shell. Hydrogen has also achieved a full outer shell. It has 2 in total. Here 2. So each hydrogen's got 2 electrons on its one shell, which is the first shell. So that is full. So both these atoms achieve full outer shell, and this is why they take part in chemical bonding. Now I'm going to show you how sometimes you have to represent the same thing. You have to show and draw the dot and cross diagrams, but only showing the outer shell, not the inner shells. Okay, let's see how that looks like. Okay, that's our oxygen, and we got the hydrogen atoms here, not showing the nucleus and everything, just showing the outer shell here. Again, the same way, I'm going to put the shared electrons of oxygen here, and we know it shares 1 electron with each of the hydrogen atoms. So I'm going to put that first before I do anything else. I can now put the hydrogen's electron here, showing that as dots. Now I know oxygen has got 6 electrons on its outer shell, so I've used 2 of this already here, 1, 2. So I have now 6. Out of the 6, I've got 4 more. So I'm going to show that here with crosses. So I've shown oxygen's electrons with crosses and hydrogen's electrons with dots. Now I have not shown the inner shell. Sometimes you're specifically asked to draw dot and cross diagrams showing just the outer shell, and this is how you do it. I've shown one example here. Let's look at a few more examples. In this case, let's have a look at an element, which is oxygen, a very common element that we always talk about. It's always represented as O2, and we know we must have seen these 2 lines. Each represents a pair of electrons. So each of this line is a chemical bond, and we now know it's a covalent bond. Only covalent bond can be represented by lines like that, and we don't do those lines when we have ionic compounds. Okay, so each of these bonds represents a pair of electrons, and for each pair, electrons are given by shared by each of these atoms. So this atom, oxygen atom, shares 1 electron, and that one electron for this bond. Let's see how that works. Following the same steps as before when we did water molecule, we're looking at oxygen here. Oxygen's electronic arrangement is like this, and we also know that it is in group 6, so its outer shell electrons are 6, and we know for a full outer shell, which is the second shell, it must have 8 electrons. So we are here on the second shell. Oxygen has got 2 shells, 2 and 6. So for this to be full, we need to decide on how many electrons it's going to need, and it's going to need 2 more electrons. So each of these oxygen atoms involved, they need 2 electrons. And we also know, once we've decided how many electrons it needs for a full outer shell, that is how many electrons it has to share, and that is how many bonds it has to make. Now this oxygen needs 2 electrons and it will share 2. That oxygen needs 2 more electrons, so it has to share 2 electrons. So let's plan for the diagram. So let's put the 2 oxygen atoms here, like so. So I'm going to put the 2 oxygen atoms here. Now I'm going to show only the shared pair of electrons. Now because I know it has to share 2 electrons with that other oxygen, there's nothing else left, so I'm going to put down the 2 electrons of this oxygen and show that with cross over here, like that. So this oxygen here, one of the oxygen is sharing the 2 electrons here, and I know that because it needs 2 electrons. Now once I know 2 electrons needed for the full outer shell, I know that's the number of electrons it's going to share, so I've done that here. For this oxygen, I'm going to show with a dot. Okay, so in the middle, as you can see, there are 2 pairs of electron, and that shows the 2 bonds here. So each of these bonds are each pair of electrons. So 1 pair for 1 bond. We draw 1 line that represents this pair of electron. Okay, now we've done the 2 bonds. Let's see how many more electrons for each oxygen that's left. We know oxygen has 6 electrons on its outer shell. So out of which we've already used 2, so that means we are left with 4 electrons for each oxygen. So I'm going to show that here. So those electrons belong to that oxygen. I'm going to show the electrons belonging to this oxygen close to this oxygen. You can put it anywhere as long as it's clear that it is still with this oxygen. It's not shared. So any shared electron I have shown between the atoms over here. Okay, now let's count. And this is a useful step before you draw the full dot and cross diagram. Okay, because then this way you're absolutely sure how many electrons you're going to put in the middle in the shared area, and how many electrons are on the outer shell that's left over. Now if you're just showing the outer shell, that itself is a diagram. You can convert that into a diagram pretty easily. Okay, so let's count the number of electrons here. Now this oxygen has achieved a full outer shell, as you can see, 2, 4, 6, 8. Now this oxygen here achieved a full outer shell like so, in a similar way, 2, 4, 6, 8. Okay, so both have achieved the full outer shell, and they are very stable in that way, and it's these pairs of electron represents that bond. So I can just represent that with that diagram, with this kind of structure. So these 2 lines represents the 2 pairs of electrons. It's really important to understand that. Okay, now we're going to move on to show the same diagram in a full-blown dot and cross diagram with circles and electronic arrangement. So here is the oxygen molecule. Each has 2 shells. That bit is the nucleus. Okay, I know it's got 2 shells because by looking at this 2, 6, I know I have to draw 2 with an overlapping area. Now remember, for covalent bonding, you have to show the atoms overlapping with each other. Just show the outer shell of the atoms overlapping. And remember, in ionic bonding, we show them separately in the form of ions and show the charges on them. We don't overlap them like this. But covalent bonds, to show covalent bonds, we need to show that the atoms do overlap in this way. Okay, let's put the oxygen's shared electrons. One oxygen's electrons, I'm going to show that we know each oxygen is going to share 2 already by just looking at this number here. So I'm going to put that first. And the other oxygen atoms, electrons, I'm going to show with dots like so, and I know each atom has now 4 electrons left. I can evenly space it out like this. You can do it the way you want, and I'm going to show that like that. And for this atom, again, it has 4 more electrons. Remember, it's got 6 electrons of its own. Now these blue electrons, I've shown here in crosses, are from the other oxygen atom. But however, it achieves the full outer shell here, as you can see, 2, 4, 6, 8, and that we've already seen. I'm going to show the inner shell electrons as well now, because that is important when you show the full diagram including all the shells. Okay, so inside you got 2. So these 2 electrons on the inner shell is for that 2 electron. So I've shown that. And for the outer shell, it has 6, out of which we know 2 electrons are shared, which is here. Okay, so that is a full dot and cross diagram. Now we can also represent the same thing with just showing the outer shell. Let's see how that is. So each of these atoms, circles, represent one oxygen atom, and I'm going to show the outer shell only because we've only got the outer shell. I'm putting the shared pairs of electrons, 1 electron from each, 2 electrons from each oxygen atom. So the electrons from the oxygen on the left is shown here with crosses, so that means I've got 4 more to show for the outer shell. So I'm going to show that here. Okay, and then for the other oxygen atom, I'm going to show in a similar way, like so. Okay, so that completes the electron arrangement, but this time only showing the outer shell electrons only and the shared electrons. And this is another way to represent and understand how to show covalent bonding and to describe them in oxygen molecule. And this explains why you have 2 lines here which we refer to as double bonds. Let's have a look at this molecule here. It's a compound HCl, and I've already drawn a single line, a single bond, which is I know it's a single bond, but I'm going to show how we know that it's a single bond following the same procedure as before. Hydrogen's atomic electronic arrangement is it's got only 1 electron on the first shell. Chlorine, its electronic arrangement is it's got 17 electrons, so 2, 8, 7. And now we know from our electronic arrangement rule, it's 2, 8, 8. That's the full number of electrons in each of the shells. So we know hydrogen's got 1 electron on its first shell. It'll need 1 more for that full outer shell. Chlorine has got 7 electrons on its outer shell. It needs 1 more electron to achieve the full outer shell. Okay, so let's write that here. 1 here and 1 here. And now we know how many electrons are needed. That is the number of electrons it's going to share. So let's draw the preliminary structure of the molecule. So I'm going to write down HCl, just showing the atoms here. And now we know it's going to be, each of the atom is going to be sharing 1 electron each. Hydrogen will share its only electron that it's got, and chlorine will share 1 of its 7 outer shell electron. Okay, now we know that because it needs 1. If it needs 1, it shares 1. If it needs 2, it has to share 2, and it has to make 2 bonds. Now in this case, we know that it needs 1 electron, so it has to make 1 bond. Okay, so let's have a look at how that is. So I'm going to put the shared electrons from chlorine with a dot over here, and the hydrogen's electron is shown as a cross. Now we've done that single bond, we've done the shared electron. Now hydrogen has only got 1 electron, so I don't have to show any other electron around hydrogen here because that's all it's got. But for chlorine, it's got 6 more. I have used 1 of the 7 electron over here, so I need to show 6 more around the chlorine. So I'm going to show that here. You can show anywhere, but it should be close to the chlorine, and it should be very clear that it is not shared in the middle. Now normally this forms a good plan to draw the full structure, or to even to describe it. Now as you can see, you're able to describe it once you've done this. If you were to describe it in words, now you can clearly describe that hydrogen shares 1 of its electron to form 1 bond, and chlorine shares 1 of its outer shell electron to make a covalent bond with hydrogen. Now for the cross and dot diagram for this molecule, hydrogen chloride, you may want to pause the video, do this on a piece of paper, and check your answer by playing the video again. Okay, showing hydrogen's electron now. I'm only using the outer shell for each atom. So hydrogen electron is there. and the chlorine is going to share one of its electron. I'm going to show that with a dot. Chlorine has 7 on its outer shell, as we know from here. So I've already used one of its electron here, so that means 6 of its electrons are left over. So I'm going to show that here on the outer shell, like so. Okay, now chlorine has achieved 8 outer shell electrons. 1, 2, 3, 4, 6, 8. So for that, chlorine outer shell is complete. So it has achieved the electronic arrangement of noble gases. Hydrogen, same thing. Its one first shell is now full with 2 electrons. As you can see, for the first shell to be full, you need 2 electrons. So that's the hydrogen chloride dot and cross diagram. You may want to try out the 2 with a full shell if you want to, but this is just showing the outer shell. Well, at this stage, you should be able to say which of these compounds are covalent and which ones are ionic to start with, and then pause the video if you want to try this for yourself and come back and play the video from here. Okay, you should have tried this. I'm going to give you the answers now. I'm going to circle only the covalent compounds. So that is a covalent compound that doesn't have any metal atoms, we know that. And as calcium is a metal, I'm not going to circle that. That one is a covalent substance. That one is not, because it has aluminum. Aluminum is a metal. Potassium is a metal in potassium oxide, so that is an ionic compound. Water has hydrogen and oxygen. As we already said earlier, hydrogen is a non-metal and oxygen is also a non-metal, so that is a covalent compound or covalent substance. Methane here is CH4. Carbon is non-metal, hydrogen is non-metal, so I'm going to circle that. Ammonia, nitrogen is non-metal, hydrogen is non-metal, so that is a covalent substance. Okay, so I've circled all the covalent substances, out of which we have already looked at the bonding in this, and I'm sure we've done this, and we have not looked at nitrogen, which is here, methane and ammonia. You may want to pause the video now, try out to draw structures or even to describe the bonding that is in nitrogen, methane and ammonia. Come back and check by playing the video again from this point onwards. Starting now with chlorine. Chlorine has 7 electrons on its outer shell, so it needs 1 more electron, and that is gained by sharing. So if it needs 1 electron, it has to share 1 electron. So I'm going to draw chlorine molecule with 2 atoms here and put the shared electron from each chlorine in the middle. So that electron comes from the one of the chlorine, and the blue crossed electron, this one comes from another chlorine atom. That one comes from this chlorine atom. So I've put the shared electron here. I know there's only 1 electron shared because it needs 1 electron. It has to share 1 electron. So that single bond is explained here. So that leaves us with 6 electrons to show for each chlorine atom. So I'm going to start with this chlorine atom here with the dots, like so, and so that's 6 chlorine atom for this, and 6 chlorine electrons shown there, and then 6 for this chlorine atom. Now once we've done that, we know exactly how to draw the dot and cross diagram. You can include all the shells or just one shell. I'm going to show that very quickly now. Here is the full shell dot and cross diagram for chlorine molecule. As you can see, the inner shell has got 2 electrons, and the next shell has got 8, and the last shell, 1 electron being shared, that's here in the shared area, and that leaves us with 6 electrons. That is shown on the outer shell here, and that's the same for both chlorine atoms. I'm going to show you how it can be done just with the outer shell. Okay, now here is just the outer shell of each chlorine atom shown here. The shared electron, pair of electron, that represents that one single bond. Remember, each pair is one bond. Now that is another way to show just with the outer shell of chlorine atom in the chlorine molecule. Let's have a quick look at nitrogen molecule now. Okay, each nitrogen atom has this electron arrangement 2 5 2 5, and the outer shell is 5. So this means each of the nitrogen will need 3 more electron, which means it will make 3 bonds, which explains these 3 bonds. So 3 electrons needed, that means it has to share 3 electrons, 3 of its outer electrons, which is out of this 5 it has to share 3. Let's now see how it can be shown with the dot and cross diagram showing just the outer shell. So let's just have a look at the 2 nitrogen atoms overlapping, and I'm going to show you the shared electron. You probably have done this. Check if you got this right. So I'm going to show the electrons from this nitrogen with the crosses with spaces between them, so I can pair them up with the electrons from the other nitrogen atom, which is over here. Okay, so I'm going to show the electrons from this nitrogen with the dots, like so. As you can see, there are 3 pairs of electrons representing these 3 chemical bonds, and we know it has to make 3 bonds, and it has to share 3 electrons each of this nitrogen. That's because it needs 3 electrons. Okay, now out of the 5 we have used 3 for the bonding. Now that leaves us with 2 electrons for each nitrogen. So I'm going to show the nitrogen, the electrons that's left over for this nitrogen, like so, and for the other nitrogen atom with crosses, and that completes our dot and cross diagram. I hope you got this right. If you have been trying to do this yourself. So let's have a look at methane now. Carbon and hydrogen are involved in this in this molecule. Carbon has got 4 outer shell electrons here, and hydrogen's got 1. So obviously carbon is going to need 4 more electron. Hydrogen is going to need one electron for a complete outer shell, which means carbon has to make 4 bonds. In other words, it has to share 4 of its outer shell electron, but it only has got 4, so it has to share all the 4 electrons. Let's have a look at how the structure will look like. I'm only going to show the outer shell this time. Okay, that's a full shell structure for methane. This being the middle one being the carbon atom. These are hydrogen atoms. As you can see, 1 electron comes from hydrogen and 1 from carbon for each of the hydrogen atoms. So there is 1 pair of electrons shared by carbon and hydrogen, and that explains the single bond between carbon and hydrogen. Now carbon has achieved a full electron configuration. It's got a full shell now, 2, 4, 6, 8. Hydrogen has also got a full outer shell, as it's got 2 electrons now, including the electron from the carbon atom. The same can be shown just with the outer shell electrons. You cannot see the inner shell of carbon atom in this case. It's just the outer shell shown. As we know, carbon has got 4 electrons on the outer shell, and it will therefore share all the 4 electrons, as it needs 4 more for the complete outer shell. So that is the dot and cross diagram for methane. Similarly with ammonia, you have for nitrogen 5 outer shell electrons, and with hydrogen just 1 electron on its outer shell. So nitrogen will make 3 bonds by sharing. So it needs 3 more electrons, so it has to share 3 of its own electrons, and that also means it will make 3 bonds. Hydrogen on the other hand has 1 electron, and it needs 1 more electron, so it will make 1 bond. So as you can see, why nitrogen bonds with 3 hydrogen atoms, because each of them can only give 1 electron for nitrogen, or share 1 electron with nitrogen. So showing in a very simple way, just considering the outer shell electron, nitrogen, as we know, is going to share 3 electrons, as it needs 3 more electrons to for a full outer shell. So I'm going to do just those first. So here is nitrogen's electrons with dots. Okay, so 3 of its nitrogen's electrons. So that leaves you with 2 more electrons. Out of that 5, 3 has been used for bonding. Now we got 2 more, which you can put anywhere on the nitrogen, like so. And these 2 are not involved in the bonding. So for hydrogen, I'm going to show that with a cross. So as you can see, there are 3 bonds here. 1, that pair of electron, 2 and 3, and then 1 pair of electron on nitrogen, which is not used in bonding. I'm going to show this now with a dot and cross diagram. Okay, nitrogen's shared electrons now. Here, here and here. 3 of its electrons are shared. 2 not shared, which can be drawn anywhere on this shell, because we are only showing the outer shell. For hydrogen, 1 electron, that's all it's got, and that's shared with nitrogen. Now you can see how nitrogen achieves the full outer shell. 2, 4, 6, 8. Nitrogen's got full outer shell. Hydrogen's got its first shell full with 2 electrons. Let's have a look at carbon dioxide very quickly. Carbon is in group 4, so it's got 4 on the outer shell. Oxygen's got 6 on its outer shell. So oxygen needs 2 more, and carbon needs 4 more. As you can see, it needs 2 oxygens. Oxygen is going to share only 2 electrons, so let's start with the smaller number. So I'm going to show oxygen's electrons here, well spaced out, and again here with a space in between and afterwards for the carbon's electrons. So oxygen's electrons, shared electrons have been done. As it needs 2, it's going to share 2. We know this already. Okay, so that leaves us with, out of the 6 outer shell electron, 2 has been shared. Now that leaves us with 4 electrons. So the 4 electrons can be put anywhere on the outer shell, as I'm only showing the outer shell now. And for this oxygen, I'm going to use the same dots, like so. So so totally, oxygens, we got 6 electrons of oxygen here. 2 of that are shared with carbon. Now for carbon's electrons, I'm going to use crosses, and it's got 4 on the outer shell here. As you can see, it's got 4 outer shell electron here. So all the 4 has to be shared because it needs 4 more. So it has to make 4 bonds, it has to share 4 electrons. So all the 4 electrons are shared, 2 each. So 2 with this oxygen and 2 with the other oxygen. So you can see why we show these double bonds between carbon and oxygen whenever we represent carbon dioxide. This is something that you're familiar with, and but its structure is like that. Each carbon is connected with oxygen, bonded with oxygen with a double bond, and this is what it means. Each pair of this electron is for one of the lines that we draw to represent the bond. And that is the end of covalent bond lesson. We have looked at ionic bonding in part 1, covalent bonding in part 2. Make sure you know clearly the difference between these two substances, and make sure you always check first, are we dealing with a ionic compound or a covalent substance. Once you made that decision, then you can go about describing them in terms of words or in dot and cross diagrams such as this.